So we just did double convex or converging lenses, and now we're going to look at double concave, which are diverging lenses. And they're diverging because what happens to the light coming through this lens is that it spreads it out so that the rays get spread out further apart. And the rays appear to have come from the focal point in front of the lens, not behind the lens. So here's a sample image. I have my object, my double concave lens, and I draw my first arrow. And my first arrow goes parallel to the center line, but then it looks as if it's coming from the focal point here rather than here, right? So then I draw it as if it's going that way. The second line is, as it always is, from the top through the dead center of the object. And I do my lost the same way. Here my image is closer, upright, smaller, and it's in virtual space. So again, if my image is upright, it looks like it's actually in virtual space. So let's see what happens with our objects. My guess is that you probably have some sense, given the pattern of the last 3 videos with ray diagrams. So this is diverging lens. I'll take my first ray and I'll take it from the top to the center line and then to the focal point on the same side as the object. And I can use a dotted line here to show that that's not actually where the rays are, but this is where the ray ends up going. And then from the center of my object to the center of my lens, and my object is right here. So my orientation, my location is closer, upright, smaller, and the type is virtual. Let's place the object right at the center of curvature. Take it to there, back from the focal point, out, and then through the center line of my lens. And whoa, it's still smaller, closer, upright, smaller, virtual. It's getting larger though, right? That's smaller, that's about 1 box high. This is slightly larger than 1 box high. Again, this is where graph paper helps because you can start to see those trends. And here again, I'm not drawing the lens anymore because as you can see, I'm pretty bad at drawing lenses. All I need is that center line of the lens and my principal axis. So I have my object, I'll take it to the center line, back from this focal point, and from the top through the center of the lens. My object is moving slightly farther away, right? So at the beginning, my object was closer to the lens, and now it's slightly moving farther away. Actually, it's moving closer to the lens. It's moving closer to the lens, and it's getting larger. So it's still smaller, closer, upright, smaller, and virtual. See what happens when it gets to the focal point. Well, it's not converging, so it's not going to disappear. And the question is, how do I do this? Oh, you just take it from here, and so it doesn't really matter. I'm not taking it from my object to the focal point. I'm taking it here, and then through the center. My object is now appearing, the image now appears to be 2 blocks high, where at the beginning, it only appeared to be 1 block high. So it looked like it's getting bigger and bigger, but it still appears smaller than the actual object. So it's still closer, upright, smaller, and virtual. So now finally, this is starting to feel repetitive. That's good because that means that you are starting to understand what to do. So now I'm awfully close to the mirror and my image looks like it's practically where I am, but it's still closer than the object. It's still upright. It's still smaller than my object, and it's still virtual. So one thing that we notice is that if I have a diverging mirror or if I have a diverging lens, my object will always be upright and virtual. It will always be smaller, and it will always seem to be closer to what the lens or the mirror than my object is. If I have a converging lens or a converging mirror, strange things happen. So when I go closer to the focal point, my image starts to look like it's getting farther away and larger. At the focal point, it suddenly disappears. And then once I'm in front of the focal point, then I flip locations from real space to virtual space. So things become really strange. So it's inverted before, and then it becomes upright and farther away. So converging mirrors and converging lenses have a similar effect, and diverging lenses and diverging mirrors also have a similar effect.